All right, let's start reading this question. It says a tank contains 30 liters of oil at time t equals 1 hour. It says oil is being pumped into the tank at a rate R of t. So that shows you here, this is R of t, where R of t is measured in liters per hour, and t is measured in hours. It says selected values of R of t are given in the table above. Use a left Riemann sum with 3 subintervals and data from the table. What is the approximation of the number of liters of oil that are in the tank at time equals 11 hours? Okay, this problem is probably, it looks familiar, probably. It looks very similar to some that we've done before. And you may know what to do just because it's in this section, so you're probably thinking to do it exactly like we've been doing all the other ones. But I want to point out a few keywords that tell us what to do and to kind of piece this together. So I'm going to take this one a little slow just because, again, it's a new problem, it's an unfamiliar problem, and I want to make sure you guys are understanding it fully. First of all, let's look at what the question is asking. It says, what is the approximation of the number of liters of oil that are in the tank at time equals 11 hours? So my final answer should be, all of these answers should be in liters, because they want to know how many liters are in the tank. So all of these have units of liters. Okay, so let's say that you just got this question randomly on a final or on an AP test, and so you're trying to figure out what to do. First of all, notice that we're looking for an approximation of the number of liters, so all of these are in liters. And then I'm looking at what information is given to me. We're given something about hours, and we're giving something about liters per hour. Okay, so it's not like we're being given anything about liters necessarily, but we're given a rate of how quickly the liters is changing, and we're given times of how much time has actually gone by. So remember that, and again, I'm just trying to tie this all back into Riemann sums again, and what the concept of it is. If we actually physically graphed this, the 1, 5, 7, 11, and then all these decimals, and we put R of t on this axis, and we put t on this axis, and remember that this is in liters per hour, and this is just in hours. And so if I had this whole curve here, and I was adding together all these rectangle areas, then you'd start to notice that the units here, let me highlight that, the units from here would be liters per hour, and the units from here would be hours. And so when we start multiplying to get these areas, we would have liters per hour times hours. And when you simplify that, notice that the hours cancel off, and so we're just left with liters, which is what we want. That's what the question's asking us. What's the approximation of the number of liters of oil that are in the tank after 11 hours? And so I hope that this is a nice visual to help you understand that, approximating these trapezoids, these are going to be trapezoids because, I'm sorry, no, they're not, left Riemann sums. Approximating these left Riemann sums is going to give us an area that approximates a number of liters because of the units that are on each of these axes. We have liters per hour times hours for base times height, and that would give us a unit of liters, okay? So that's kind of how I want you guys to make the connection back to what we're figuring out. If we can find the area under the curve, if we can approximate the area under the curve, we can approximate how many liters of oil are actually in the tank at 11 hours. So, let's come back. Let me erase all this. Alright, so now let's actually do the left Riemann sum. So, we have these 3 subintervals from 1 to 5, 5 to 7, 7 to 11. Notice those are all different lengths, so I can't actually do it in one full summation, I have to do it individually. So looking at the first rectangle, and remember that I'm using left Riemann sums, so I'm always coming from the left. So it might help you if you actually graph this out and actually look at the left endpoints. I'm not going to do it in this case, but if you need to, if you're unsure about why I'm choosing the numbers that I'm choosing, go ahead and graph it out and then draw the actual left rectangles, and you'll see why we are choosing these. So for our first rectangle, it has a base of 4 because the distance between 1 and 5 is 4. So let's just look at all these distances really quick. So this is a distance of 4, this is a distance of 2, and this is a distance of 4. So for my first rectangle, it has a distance of 4, or a base of 4. And the height from the left, because remember from the left, would be this one. So that's 2.3. Plus, the next one has a base of 2, and the height from the left of this rectangle is 3.1. And then the base for the last one is a base of 4, and the height for that is 4.5. Now, unfortunately, you are not allowed to use a calculator for this problem. So on our benchmark at least, remember that I'm giving you a little bit of extra time, so you only have 19 questions, but I'm giving you the entire hour to finish them. And so especially for a question like this that maybe requires some multiplication with decimals, and you're going to have to do that by hand. Of course, I want you guys to have a little bit extra time. So go ahead and multiply those out by hand. I know that you know how to do it, but maybe when you guys get rushed, you kind of make mistakes. So pause the video and just make sure that you guys do that really quickly. Alright, so hopefully you've multiplied out and added together some numbers here. So notice that I multiplied out, I showed my work up here. Again, I didn't use a calculator because you guys aren't allowed to use one on the test either. So we have 9.2 plus 6.2 plus 18, and then I added them together over here and got 33.4. Now, I want you to be very careful because you might feel so accomplished at this point and actually finding your answer that you get so excited that you go back and actually choose 33.4. And I'm going to let you know right now that is not the actual answer. So I need you to be super, super, super careful, especially in these long word problems when there's a lot of information. When you first read the problem, you kind of skim through it really fast and figure out what you need to do and do it really quick. And then as soon as you see that answer, you get so excited. And they put it on there for a reason because they want to make sure you're actually reading the whole problem and understanding what it means. So before we choose A as our answer, let's go back and actually read the problem one more time and make sure that we actually know which one the correct one is. It says, a tank contains 30 liters of oil at time t equals 1 hour. That piece of information is the first sentence, but it is so important and it's so easy to skip over because your brain kind of forgets about it by the time you've actually finished what we've done so far. It's so important because of this. Here's what it tells me, and we kind of talked about this earlier. I don't remember which problem number it was, but we talked about it earlier where it's telling you how much we're starting with at 1 hour. So the tank already has 30 liters of oil in it at 1 hour. All right? So I hope you understand that at 1 hour when this time starts, because right here we're starting at 1 hour as well, at 1 hour when this time starts, the tank already has 30 liters of oil in it. Then, over the next 10 hours from 1 all the way to 11, okay, so from 1 hour to 11 hours, it accumulates this much more oil in the tank. So this is how much oil in the tank accumulated or was added to the tank from 1 hour to 11 hours. Okay, but they don't want to know that. They don't want to know how much oil has accumulated between those two times. They want to know, use this approximation to tell me how much oil is actually in the tank. Not how much more oil, but how much oil total is in the tank. So if we started at 30 and we accumulated 33.4 more liters of oil, then now we should have a total of 63.4 liters of oil in the tank, which is actually answer choice D. So that's why I say be very, very, very careful, especially with these longer word problems. Go back and when you find your answer and you get all excited and you see it, go back and read the question one more time. Make sure you've used all of the information that's in there because they want to make sure that you guys are really paying attention to what they're giving you and not just falling for the easy choices or the kind of trick choices that they put in there. So I hope that's a lesson to be very careful and to kind of pay close attention to detail as you go through.